Welcome back to geometry. I hope everyone had a great spring break. We are dealing or learning 7.4 today, similarity in right triangles. So we're asked to label this triangle ABC, so let's do that right now. Let me grab the pen, and we're going to put point A up here, point B will be our right angle, and C will be down at the base. They are asking us to draw an altitude from B to side AC. So if we think about an altitude, it's going to create a 90 degree angle with side AC. If I drew this line out here, it wouldn't create a 90 degree angle. So it looks like in order to do this, this line would have to be drawn about right there. And so we can put a 90 degree angle here and a 90 degree angle there. And let's label this new point D. Alright, next we read that when an altitude of a right triangle is drawn to the hypotenuse, there are actually three similar triangles. Okay, and let's change the color here. Here's our small triangle. Alright, our medium-sized triangle is in green, and then let's go in yellow, the triangle on the outside, this all the way around, all the way down to here, and then all the way back. There's our large right triangle. So not only are there three triangles, 1, 2, and 3, but they're all going to be similar triangles. Okay, so let's separate these and learn why they are in fact similar. The first thing that we want to do, which is a little tricky, is we want to separate these three triangles so that they're all facing the same direction. Okay, so since our pink triangle is our small one, here's our small triangle right here. It looks like A and D are at the base. D is your right angle. Here's vertex A, and then B will be up at the top. Alright, and then we're going to do the same for the middle-sized triangle. That's our triangle in green. So for the middle-sized triangle, we have a right angle at D. We have our base would be B, and then C will be at the top. And then for our large triangle in yellow, we have angle B. We have angle A, and then up at the top we have angle C. Alright, now if we wanted to prove like why or how are these triangles similar, remember that in order to prove that triangles are similar, we have three methods. We have side, 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 we have side, angle, side, and we have angle, angle, angle. These are the three ways we can prove that triangles are similar. Since we're not given any of these side lengths, we can't use side, side, side. We can't use side, angle, side. So we're left with using angle, angle, angle to prove that all three of these triangles are similar. Alright, and we can do that. Let's start by looking at the big triangle to the middle triangle or medium triangle. And so when I look from big to medium, I see that angle C is congruent equal to angle C. And why is that? Well, that's by reflexive. Okay, because they share the same, they are the same angle. So I can put a mark and a mark here. Angle C is congruent equal to angle C. Furthermore, I see that angle D is congruent equal to angle B, and that's because all right angles are each congruent. Okay, so now by theorem 4.1, I can say that angle B is congruent equal to angle A, and that was by theorem 4.1, which says since these two angles are the same in both triangles, that means their third angle has to be the same as well. So I can put 2 marks here and 2 marks here. So by showing all of this, I've shown that all three angles are each congruent. So by angle, 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 Similarity, the big triangle is similar to the medium-sized triangle. All right. Next, let's go from um, big to small. Okay, so if I want to go from the big triangle to the small triangle and trying to prove that those two triangles are similar, we can do the same thing. I see angle A is congruent and equal to angle A. That's by the reflexive property. Okay, so I'm going to put 2 marks here and 2 marks for angle A. I see that angle D is congruent and equal to angle B. That's because all right angles are each congruent. So right angles are congruent. And then by theorem 4.1, I can say that angle B is congruent and equal to angle C. And that was theorem 4.1. Since these two angles are the same in both triangles, that means their third angles are the same. So we'll put 1 mark at angle B. So again, by angle, 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 I have proven that the big triangle is similar to the small triangle. All right, so the last one that we have to prove is the medium-sized triangle is similar to the small triangle. And what's interesting here is if we try to do that, we can't use reflexive properties. We have angle C, angle B, and angle A. We only have angle D is congruent and equal to angle D. That's the only one that I can say for sure. But if you recall back from a previous unit when we said A is equal to B and B is equal to C, that means A is also equal to C. So by the transitive property, since the big triangle was similar to the medium triangle, and the big triangle was similar to the small triangle, that means by transitive property, the medium triangle has to be similar to the small triangle. All right, and then our theorem is down below. And so all the work that we just showed here says that the altitude of a right triangle drawn to the hypotenuse creates 3 similar triangles: small, medium, and large. All right, next page. We learn a new term here, and it's called the geometric mean. Now, before we explain this, the mean means average. So this is an average in geometry. Now, what we're most familiar with is an algebraic mean or an algebra mean. And so the way that we do this is if you scored 10 points in a game and then you scored 2 points in game 2, then you're averaging 6 points per game because we took your 2 point totals and then divided by 2 and we would get 6. And so an algebra mean makes sense to us. It's easy. We've seen it time and time again. A geometric mean is an average as well, just like we do in algebra, but you haven't probably seen it before because it's used in geometry. And so how we do that is we're going to take our 2 numbers. So again, let's use this first case where we scored 10 points in game 1 and we scored 2 points in game 2. Okay, and so I'm finding the geometric mean of our 2 point totals. And so we set up a proportion to solve this. We get x squared is equal to 20. Square root both sides, we get x is equal to 2 rad 5. Okay, and so that would be the geometric mean of 10 and 2. So we just do the same thing for each problem. We're going to take 8 over x is equal to x over 2. X squared equals 16. X is equal to 4. 4 over x is equal to x over 9. X squared equals 36. X equals 6. 10 over x equals x over 6. X squared equals equals 60. Square root both sides. X equals 2 rad 15. Last one, 10 over x equals x over 4. X squared is equal to 40. X equals 2 rad 10. Okay. All right, next we have this new term called a corollary. This is very similar to a theorem. Okay, so we have this long theorem that says the length of the altitude to the hypotenuse of a right triangle is the geometric mean of the lengths of the segments of the hypotenuse. Okay, this is a lot of verbiage, and there's many terms here being thrown around. Okay, and so what I've done for you is I basically simplified everything that's in here so that this is kind of a shortcut way that it should make more sense. And what this is really saying is that when x, or the unknown, is in the middle, which is our altitude, then you're going to find the GM of the part and the part. And what we mean by that is if we highlight this altitude x, it's going to touch this part of 4, it's going to touch this part of 9. And so the way that we can solve for x is we take the GM, or the geometric mean, of 9 and 4. So we have 9 over x equals x over 4, x squared equals 36, x is equal to 6. We can do the same thing with y. Okay, y is in the middle, it's an altitude, so we're going to find the GM of our two parts. We have this part 5 and this part 8. So 8 over y is equal to y over 5. Y squared is equal to 40. Y is equal to 2 rad 10. Alright, this problem we have to work backwards, and here's why. Note that in all these problems we had x and y was in the middle. Okay, now we have m, or the x or the y, is at the base and it's a part. Okay, so let's not forget, and actually I should have been showing my work better here, so let me set up this first problem again. What I should have done is I should have said in this problem, since x is in the middle, I'm going to find the GM of 9 and 4. Okay, and then here's my work to solve for the GM of 9 and 4. On this problem, we're going to find the GM of 8 and 5. Because y was in the middle, it's the altitude, and our two parts are 5 and 8. Okay, and so our work to solve that goes here. On this problem, I need to find the GM of our two parts, which is m and 4. Okay, and we actually get to work backwards because we're told that 8 is the altitude. Okay, so what I can do here is I'm going to take m over 8 is equal to 8 over 4. Now remember that when x and y, or m, is the altitude, then we form an x squared and a y squared. We don't have that here because m is not the altitude, m is at the base. So we get 4m equals 64, m equals 16. Alright, our second corollary, this is our corollary number 2. It says a lot of things. It says that the altitude to the hypotenuse, and then blah, 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 blah. What they're really saying here, and it's been shortened down for us so that we can have a shortcut way to remember what all this is saying, is that when x is a leg, then we find the GM of the part and the whole. So as we look at this problem, we see that x is no longer the altitude, it's in the middle. X is now a leg of the big right triangle. So as a result, if you highlight x as a leg, you see that it's going to touch the part of 3. Okay. However, now we need to take the GM of the part and the whole. We do not take the GM of 3 and 9. Rather, we're going to take the GM of 3 and 12, because the whole length is going to be 9 plus 3, which would be 12. So just like we've done in those last 3 problems, sorry about that, let me recenter this. We're going to take the GM of the part, comma, whole. And so we have the geometric mean of 3, comma, 12. 3 over x equals x over 12, x squared equals 36, x is equal to 6. Alright, next problem. let's highlight y. We see that we have y is a leg. So since y is a leg, we know that it's going to be a GM problem where we take the part and then the whole. And so the part of y is going to be 9 and the whole is going to be 12. So 9 over y equals y over 12. Y squared equals 108. Reduce 108 down. What's that going to be? If we reduce 108, does 36? No, that'd be 2 and 54. 2 and 27. 9 and 3. So that would give us 6 rad 3 is equal to y. Alright, just like in that last 3 problems, this one we have to work backwards. So 10 is actually the leg, and we have our part 8. So for this problem, we're going to take the GM again of the part, comma whole. And we take the GM, and our part is 8, and our whole is going to be 8 plus x. So we have 8 over 10 is equal to 10 over 8 plus x. 100 equals 64 plus 8x. 8x is equal to 36. X equals, I believe that becomes 9 halves. Alright, we're going to skip this first problem because it's actually more challenging of the two. So let's do the easier one first. To find n, n is in the middle. It's the altitude. This becomes a part-part problem. So we're going to find the GM, and this is for n. We're going to find the GM of 5 and 20. 5 over n equals n over 20. N squared equals 100. N is equal to 10. Alright, m is a leg, so to find the leg, it's a part whole. We take the GM of 5 and 25. So 5 over m equals m over 25. M squared equals 125. M equals 5 rad 5. Alright, and then p is also going to be a leg. So for p, we're going to take the GM of 20, which is the part, 25 is the whole. 20 over p is equal to p over 25. Let's multiply that out. 25 times 20 is going to be rad 500. So p squared equals rad 500. This gives me 10 rad 5. Alright, moving over to the other problem, a little bit more challenging here. We have 3 unknowns, just like in this problem. And the first thing that I want to do here is, if we look at this right triangle, we see that we have this large right triangle. We have 5 and 12. So let's do a quick a squared plus b squared equals c squared. And so that's going to give me 25 plus 144 equals c squared. 169 equals c squared. 13 is equal to c. So we found that this entire length is going to be 13. So since this entire length is going to be 13, we can use that to solve. So here's what I would do first. When we look at 12, 12 is a leg, and we know that to find, when dealing with the leg, it's going to be part and whole. So I'm going to find the GM, and again, this is for the leg 12, find the GM of m, and then the whole is going to be 13. Well, to find the GM of m and 13, I take m over 12 equals 12 over 13. 13m equals 144, and then m would be 144 over 13. And let's convert that to a decimal. 144 divided by 13 is going to give us 11.1. Alright, so m is going to be 11.1. Alright, well, if m is 11.1 and you add up m and n and it equals 13, we know that n would have to be 2.9. Actually, check that. M would be 1.9, right? 1.9. There we go. Because 1.9 plus 11.1 would give us 13. All right, then for P, I would just, well, there's a few ways that we can do this. For P, I can take the GM of 11.1 and 1.9, okay, or I can say that P squared plus 1.9 squared is going to equal 5 squared. All right, A squared plus B squared equals C squared. So this would give me 11.1 over P equals P over 1.9. Let's cross multiply 11.1 times 1.9. Second square root. Actually, let's do that again. 11.1 times 1.9. And that didn't work again. Sorry, I'm having scientific calculator issues. 11.1 times 1.9 equals second square root 21.09, 4.6. So P would be equal to 4.6. If we were to use A squared plus B squared equals C squared, let's just make sure that the answers match. That would give me 1.9 times 1.9. And then 25 minus 3.61, second square root. And we get 4.6 as well. Alright, so both methods would give us the same answer. Alright, last problem we have is the algebra review. We're going to graph and find the point of intersection. -3, rise 1, run 2, down 1 over 2. 3x minus 2y, -2y equals -3x plus 6. That means y equals 3 halves minus 3. So it actually intersects here. Rise 3, 1, 2, 3, run 2, down 3 over 2. And so here are the two lines graphed, and there's our point of intersection, 0, -3. Thanks for joining us. See you next time.